Okay, so here we go. Hi, everyone. I'm Andy, and I'd like to welcome all of you to the Cybersecurity with Python and the Microbit workshop. This is day 1 of 3. This is the summer 2023 installment. That's July 24th through 28th, every other day at 3 p.m. Pacific. With you today are me, Andy Lindsay, Ari Alvarez, and Stephanie got left out, but we'll get to her in a couple slides. Sorry about that, Stephanie. Here is a link to this slideshow. This slideshow is going to be useful to refer back to. It's going to have a lot of useful links, and what I'm going to do is paste that into the chat. Bear with me a second here. Okay, now it's not necessary to have this slideshow up in front all the time, but the one thing you might end up doing is wanting to switch to the slideshow if there was something on, a couple slides ago that you're interested in. While I'm moving ahead, it'll be useful for that, and then in the future it'll have a lot of helpful links that you can go ahead and revisit. Now, for those of you who have a single screen, if you have 2 or 3 screens, that's great, because all you'll need to do is put the slide or the Zoom workshop on one screen, and then there can be another screen where you've got your Python online editor. And we have some audio interference. Can everybody who has any background noise going on self-mute? That sounds really good. Okay. So if you have a single screen, one thing I recommend is to click this. If you move your mouse around over the presentation, which is probably filling your screen, you'll see a view button in the upper right, and you can click that and then select exit full screen. At that point, you'll be able to resize the screen. And what I recommend is resizing it so that it looks more like this, with the screen left or right, your preference, and then your Microbit Python editor on the other side. That way you'll be able to see what's going on, and you'll be able to make adjustments to your code, or copy from the chat window and paste into your code. That is another thing. If you move your screen around, there will be a set of button controls either at the top or bottom of your Zoom window, and it would be a good idea to open the chat and just be able to get to that when you need to. Okay, so with you today, this is me, Andy Lindsay, on the left, Education Manager and Company Vice President Ari Alvarez in the center, and Stephanie Lindsay, our Product and Documentation Manager, on the right. About your speaker, that's me, Andy. My training is in electronics engineering, but shortly after I graduated, I started working at Parallax and started developing educational materials, and have been doing so ever since. That was in 1999. And so yeah, up till now, that's what I've been doing, is developing educational materials that are mainly focused on electronics and other STEM lessons, including cybersecurity. So more recently, I've worked on the Cyberbot robot. This is a nice little vehicle to give a physical manifestation to your or representation of your cybersecurity lessons, and also a set of electronics workshops called What's a Microcontroller. And I put links into some of the older workshops for these guys. I should probably update those. I just realized. So after this course, that'll be a to-do or after this workshop session, that'll be a to-do for me, is to get the most recent of each one to put here. I'll also show you where else to find workshops in case you're interested in doing more of this on an at your own pace basis. Parallax, in case you're interested, is a small company just outside of Sacramento in the center of California. And we have about 20 employees, have been in business since 1988 and started developing educational materials in 1997. One of the main emphases of Parallax are those programmable chips that go inside products that you're probably familiar with, and then also inside cool inventions. Stephanie, can we mute everybody? I'm still getting a lot of feedback. It may be coming from my system, but it kind of sounds like it's coming from one of the attendees.
Yep, I'm working on that.
Thank you. Thank you very much. All right.
Yes, the interface has changed slightly since last time, so I apologize for that.
Okay. Yeah, I'm noticing that too. Bear with us, everyone. We're trying to keep up with the new Zoom interface. That said, though, do feel free to unmute yourself if you want to jump in with a question, and then just go ahead and remute yourself after you're done. And can you clarify what I need to do to click or turn on? Let's see here. Using Zoom app and SoundWorks might need to allow permissions.
Yeah, we had two people that were having issues with the sound. They were not hearing anything.
Okay.
We confirmed the sound is working. So,
okay.
Carol, we were talking about muting yourself. You have a microphone, and you can also stop video if you want. Stop, start video, but you can also mute.
Okay, good. I see one person has got their sound going. And I'll let you guys keep on working with Carol. All right, so yeah, microcontrollers are what Parallax started with, those programmable brains that go in products and inventions. And at the helm of Parallax, or the guy who started Parallax, his name is Chip Gracie. He is still our chief inventor. Ken Gracie is our company CEO. He keeps the business running and is a generally great guy. And rewinding back to the late 90s, Chip Gracie, this guy, invented something called the basic stamp. And this really changed everything for both hobby and educational electronics, because before this point, there wasn't really anything that was super easy to program and also connect to circuits to make your inventions. And so generally it took a lot of technical knowledge. And so this lowered that that barrier or hurdle. And it's something that suddenly became accessible in high schools as opposed to technical colleges and universities. And moving forward a little over 20 years, we have the microbit is I think the current best device for lowering accessibility hurdles in terms of microcontroller lessons. And to show you how this works, I'd like to get started with just some really, really basic lessons from the Make It Code It page. So I'm going to copy this link here and then paste it into the chat. And then you'll want to open your chat or just possibly follow the link. I'm going to follow it, and I'll go ahead and paste code in your chat that you can harvest from, and then that'll make it easier to just watch along. So I'll go ahead and so as an example, since you all have copies of the slideshow, if you want later to go back to Make It Code It, you can simply click the link and then follow it. Now at the Make It Code It site, here we have the microbit doing some really basic stuff. And these lessons are super lightweight. They're suitable for middle school. And it's a very non-technical approach to learning how to program. For example, we start with displaying something. And so the student will follow the link. And when they do, they'll see a nice introductory video on how to display something. And they'll learn a little bit. And then they have an option of using make code blocks. And this is what the display a heart program looks like in make code blocks. Or see this tab right here, right below step 2 code it. There's a make code tab and a Python tab. And so this shows how to display a heart with Python. And I'll skip running this for now. We'll run something in just a minute. But what I want to emphasize here is, okay, that's step 1, communicate. Step 2, let's put something inside a loop so that it repeats. And so here is the beating heart. And with the beating heart, you'll see that there's in make code, this is what it looks like. And again, in Python, it looks like this. And so this is a repeating loop, just like one you probably tried in your homework. I hope everybody got to try it in the homework, the while true loop, where statements below it have to be indented if they're going to be repeated as part of this while true loop. So here's a second lesson. The first lesson was communicate something with a display. The second lesson was display a beating heart by displaying one version of the heart, a sleep statement to wait for half a second, and then a smaller version of the heart, and then another sleep statement. And when you come back to, this is the overall effect that you get from that script. So it moves on. An emotion badge. This one adds in conditional statements like if you press the A button, then display a smile. If you press the B button, then display a frown. You can shake the microbit and have it select a funny looking face. And then as you continue to add in computer science concepts again, and again, this is on a very lightweight level, eventually you'll get to something like a step counter. And a step counter pretty much has all the coding elements that I would consider to be the basics. And so looking at it, we have a variable. The step counting value, it starts at 0. Then we have this loop that repeats everything below and indented from it infinitely. And then what it does is it checks its built-in accelerometer. And if it detects that you gave the microbit a good shake, like you might if it's attached to your foot and you're walking, what it will do is it will add 1 to its steps count. That's arithmetic. Then it displays. So we have variables, remembering and storing values. We have repetitions, which is something, again, these are the basics of scripting. We have conditionals like if, and then we have arithmetic, adding 1 to a value. And then we have, of course, more displaying the number of steps. And so this is a very lightweight, easy, fun, intuitive way to dive into programming. And I should point out also that in addition to the code example, basically every one of these lessons starts out with an introductory video, then a little bit about how it works. Then you try out the code, and then the students are programmed to, or are challenged to improve it. And they have to put their hands on the keyboard and modify the code usually to do that. I think I'll have us all try the step counter. It's a lot of fun. So here is the Python code. That way we can all make sure that we're connected to our microbits as well. What I'd like you to do is like here where I'm showing the the microbit modules. When I paste this in, you can copy it and then select all of whatever scripts in there, like probably something short. Might look like this, or it might be the default script that you get when you open the python.microbit.org editor. And so you'll take what's in the chat window after I send it to you, paste it over whatever you've got in the editor, and then hit send to microbit. And then this microbit, the one on the right, is the one that received the program. And all I have to do is give it a shake, and it will increase its count. Okay, so here it comes to your chat window. So I'd like everybody to try that out and make sure that you can load into one of your microbits that's connected to your computer, and that you can give the microbit a shake and it'll increment the value it displays. And if you could give me a thumbs up, either by making that gesture. Oh, looking good. Some of you are really fast. And so either a thumbs up by just doing the gesture, or there's also a reactions button. Usually I see it by clicking I have to shake my mouse. So, oh, good. Good job, Tom. Good job, Alex. Love it. There's in the control buttons for Zoom. I know for myself, to send a reaction, I have to hit the three dots that say more, and then you can, where is that? Yeah, unfortunately, I don't think I have the option for reactions because I'm presenting. Stephanie?
Andy,
Or yes.
and if you put your cursor over your own image, your name, what have you, in the right-hand corner, I think that's where you find those the ellipses, right?
Oh, very good. Okay, so thank you. The suggestion was to click over where I see myself, and then I can see.
Yeah, you don't have to click. You just put your mouse over it, and in the upper right-hand corner.
Okay, all I see is mute there. What I'm looking for are the thumbs up that make it.
I guess it varies because, you know, for mine, I'm able to see several other things. I'm not sure.
Okay,
Maybe
does anybody else see a thumbs up option over when they put the when they hover over their picture in the upper right? Okay.
It should be next to the recording button at the bottom right-hand side.
Okay.
So it's share screen, record, and then there's reactions.
Okay, which is very different from mine. Sorry, but oh, you know what? I could have figured out all this. Sorry. I also have an attendee computer. And so if I tap the green button for the controls, okay, yes, that's exactly right. The reactions are just to the right of record. Okay, so thank you. So that's a good way to communicate whether or not you completed it. And I also appreciate the thumbs up that came through the chat. Okay, looking good. So we're through that. And how many of you have both microbits connected? Can I get some more thumbs for that? Okay, good job. For those of you who, as a first warm up to do for 2 microbits, there's a send a smile. Here it is. And what you can do is put this into both of your microbits. And then when you press the A button, you can send a smile from one microbit to the other. I'll go ahead and paste that in so you guys can paste it into both your microbits. So there's the program in your chat. And then basically want to load this into both microbits. Send to this microbit and send to that microbit. And then when I hit the A button on one microbit, a smile appears in the other one, and vice versa, as the beginning of some of our radio fun. And go ahead and give me a thumbs up when you've got that running. Nice. Good job, everyone. Looking good. Thank you.
May I ask a question? I sent the code to my first microbit, but then it won't seem to let me switch to the second microbit. Am I
Okay.
missing something?
Possibly, let's see. I think I'm hoping the best way to fix that is to essentially, you have one tab open with that's connected to one microbit. So if you open
Okay.
another,
I didn't do that. Okay.
okay, and then
I got it.
Okay, great. But do let me know if you, because there are still a few possible pitfalls. But the idea is, yeah, to have 2 microbit Python editor tabs open. And then as you hit the connect button, or when you hit send to microbit, it will let you choose between one or the other. So what I'm going to do is take us back to
And while Andy does that, I just wanted to clarify, usually when you teach, you don't have to deal with all of these because you don't have 2 microbits connected to a single computer. Each student has 1 microbit, so you do as a classroom. The experience is as a classroom, so it's much easier. Here you have 2 microbits and Zoom, which is takes a lot of resources from your computer, so is as tricky as it gets. So even Andy sometimes struggles because on top of that, he has an extra camera to show you what the microbits do. So he's at the limit of what that computer can do. In the classroom with just 1 microbit, it's just easier, just much easier.
Yes, it's very easy, in fact. And so let's keep my fingers crossed that everything's going to work out here. I was just going to demonstrate that when you have 2 microbits connected to one computer, generally, instead of hitting send a microbit, you can start by clicking the 3 buttons next to it and selecting connect. And I don't really need to see this anymore, but it does tell you, hey, here's how to, plug in the microbit. And then here is how to select the microbit and then select connect. And you're going to have to do that after you hit next. And then here we are. But in this case, there are 2 microbits in the list. So I'm going to select the first one, which is ending in the number 200,000 here. I'm going to connect to that one with this editor tab, and then going to the other tab and hitting connect. And then I'm going to select the other one, which is ending in about 300,000 with its serial number here. So I'll connect to the other microbit. And also another way to say that is basically with this tab, I'm connected to the first microbit in the list. And with this tab, I'm now connected to the second microbit in the list. And as Ari pointed out, it's not nearly as challenging when you're in the classroom because you don't normally have 2 microbits connected to the same computer while you're in a Zoom meeting. So bravo everyone for getting this running. And if anybody is having any challenges with this, just let me know and we'll see if we can get you unstuck. We won't be doing a whole lot of this today. We'll save most of that for Wednesday, but I just thought I'd show you. Here's a radio network example where basically the built-in radio in this microbit sends out a message to the built-in radio in that microbit when you press the A button, and then basically both of these loops are set up to listen for radio messages that are incoming. They alternate between checking to see if we received a message and then checking to if you pressed a button. So if the button is pressed, you clear your own display and send a smile out the radio. And then if a message came in with radio receive, then we display the smile. Display.show image.happy. All right. Let's see, I see some notes here. The names are hard-coded and based on their internal unique ID, correct? So you can't manually rename the microbits. Thank you, Stephanie. All right, so that's kind of a little intro on how students, there's many different approaches. I'll talk more about that in a minute. I just wanted to mention that this is a resource that can be really nice for younger students, or as a good icebreaker for high school students. And there's lots more of this kind of material in 2 2-hour workshops that I did for the Granite School District in Utah. And we have the YouTube links here and the presentation for it down below.
Can I hop in with a question?
Yes, please.
If there are 3 microbits, how does a radio know? And in a classroom setting, will all the microbits with the same code display the smiley face when one microbit button A is pressed? It sounds like we have the students running ahead here and looking into subjects such as network topologies and so forth, and all the
It's
things
a very good
cybersecurity is
question.
based
Yes,
on.
exactly. That is exactly right. So it's a great segue into network topology, and this nice open radio channel that we're using, provided everybody's set to group 2, they're going to see that radio traffic. If you set your group number to a different value, you can split off into any of 256 groups. There's also a radio channel that you can select, and then an address, which causes the number of possibilities to become prohibitively high to hack. And I'll talk about that a little ways down the road. But yes, for now, yeah, having the radios and the microbits able to communicate over, in this case, an open channel where all the other microbits can see the traffic, provided they're running the same program, is a great way to start talking about how the internet communication is fundamentally open, and how things like encryption can really help prevent problems, how things like choosing a different group or a different radio channel can give you some privacy. But yeah, encryption, of course, is going to be the most important factor here. And yes, it segues into many other lessons, and I'll be talking about that more as we continue. Just wanted to talk about, I'm calling it the microbit scripting depth chart. We have the microbit resources that we just took a peek at as a starting point. And then there's cyber.org, which has a number of cybersecurity lessons that we'll talk about on Friday. Now, this is a little bit more coding intensive, but not much. And so, again, we'll look at what they've got on Friday. And then the parallax material that I'll be talking about today and on Wednesday, and then a little bit of Friday, are primarily targeted at high school students, though you can bring it down to middle school, and then I can talk more after the session about bringing it down to middle school level. So you'll see a number of microbit middle school level resources here, upper grade school and middle school here, and then these lessons are primarily targeted to high school, but can be adjusted accordingly. All right, to give you a little bit more of an idea of what we're doing today, we're still in the middle of intros and overview. We'll be talking about using the software just a little bit, and then a review of some of the scripting stuff you did as homework getting ready. I'll talk about a few more things that end up fitting into the cybersecurity scripts that we'll be running on Wednesday, and hopefully get into some of the basics of radio communication we'll see how far we get. But I do hope to do radio basics by the end of the day. Okay, so how does the microbit really relate to cybersecurity and IoT? Well, it's a small device. It's got a display. It's got buttons. It's able to communicate over a radio network. It also has built-in sensors. It has a built-in compass, a built-in tilt and shake accelerometer sensor, a speaker. So it's a nice little system. It's almost like a microcosm of a cell phone or an IoT device. And so coming back here, I just added a couple of articles to talk about how IoT has it's really an increasing concern, because all these devices, like the button to reorder your detergent automatically that goes to the internet and says that your Amazon needs to send you more detergent, and your smart toaster and all that. As these things proliferate, there's going to be more and more ways that hackers will try to exploit to get into networks. And most recently, I added an article that Stephanie forwarded to me about the Biden administration working with companies to make IoT devices safer. And so I think there's going to be a lot of employment opportunities, a lot more employment opportunities at the embedded level, where you have a device that's a computer brain, and as it gets designed, cybersecurity is going to become more of a concern. And that loops back to the microbit again, since it is kind of a microcosm of an IoT device. I also added some articles about some cyber attacks that were performed on military installations, because electromechanical stuff, like I talked earlier about the Cyberbot robot, this little guy right here. Well, this is an electromechanical system that, because it has a microbit and because it can get on a radio network, it is vulnerable to attack, just as electromechanical uranium refineries and weapons depots. And again, you can click any of these pictures and then follow the link to see the article. And with that, let's take a look at some of the cybersecurity material. So I'm going to follow this link to learn.parallax.com/cyberstudents. So this is a quick link that you can take to see our cybersecurity material coming at you to the chat. But I'd also like to back up and just navigate to some of that through learn.parallax.com. So this is the page without the /cyberstudents. And if you look at language, for example, you can see the cyberbot and cybersecurity. I'll start with the cyberbot because this is a superset of the cybersecurity lessons, and more robotic stuff. So this is and it takes us to a choice where we can go cybersecurity, which we'll be spending most of our time in here. But I want to show you the cyber bot because that's where a lot of this material originated from. And so the CyberBot robot has some basic prerequisites that have to do with coding. And so there's a lot of computer science and Python scripting lessons. And we're currently, by the way, in the process of upgrading our documentation from the older V2 editor here to the newer V3 editor, which we'll be using during the workshop. Writing microbit programs is one where you have already visited quite a few of the links. So for example, this might look familiar, scrolling text. So this was where it scrolled hello, and it was one of the things that you got to try in the homework. After that, for the CyberBot robot, we talk about adding modules to your microbit. And so if you were ever curious about import radio, that's a module that allows you to use the radio features like radio.receive. There's another module that's a biggie called microbit, and that allows you to use display.show and display.clear, image.happy, and all those guys are part of the microbit module. And to learn more about that, you can, well, there are several things you can do. You can, in the left sidebar, you can click reference, and it has some information about things like variables, display, the buttons. And so again, this is taking you through a lot of the programming basics, decision-making, loops. Then we get to the accelerometer, comments, math, etc. There are some ideas, and they send you to some of the tutorials we just looked at. And then it talks about the API. And so if you're looking at the microbit API, it will talk about the button object. So here it is. And it explains what you can do with button. So that's the API. The project is where you can add modules. And when you're working with the CyberBot robot, there's an extra module in addition to the built-in ones like microbit and radio that we add. And it appears in this area to allow the microbit to talk to the CyberBot robot. And then we've got some settings. And then down here, there's a nice little help button. And for example, if you want to go to microbit support, that's the way to get there. MicroPython documentation, if you want to learn more than what's up here in the reference area, you can click the question mark and go to this, which is a nice little step-by-step tutorial, another way, slightly more in depth than the Make It Code It site that I talked about first. And they have their own hello world and their own decision making with buttons. And so this is another one where there's good tutorial material, especially for learning Python yourself. And because I recommend going through whatever you're having the students do on your own ahead of time. It helps a lot when the students come up with questions. And boy, do they ever come up with questions. Okay, so I think I'm getting a bit ahead of myself here. I'm going to come back to these, some of the buttons down here and talk about saving and naming your project and all that. It's on an upcoming slide. Anyway, scrolling text, and then variables, solving math problems, making decisions. So this here at learn.parallax.com is yet another take on learning those basics. And this is what you went through for the homework. So essentially, before starting the cybersecurity, there is a number of scripting basics to cover in Python. And that's really more computer science lessons than cybersecurity. But then we get to the cybersecurity where we start creating networks and discovering that they have vulnerabilities and that things we want to do can end up being interfered with by other parties and monitored by other parties, and et cetera. And so we start learning about encryption and how to address sniffing attacks, brute force attacks. And it looks like this slide is a little out of date. I apologize for that. I need to add in, let's see. Malformed packet attacks and defenses needs to go in there. And we add more tutorials periodically. And so this one came up most recently. Even though these are feature the Cyberbot robot, there's a number of microbit only lessons that can be done within these two chapters here. And so, for example, with the tilt radio control, actually the majority of it, although yes, in the end, it's set up so that you can use a microbit and tilt it to control or to orchestrate the motions of a radio-controlled Cyberbot robot. The majority of it has to do with learning about how the built-in accelerometer works and how the math and physics work to make the application go. And really only at the end is where we start working with the robot. So that's why this is even included in the cybersecurity section. Okay, especially if you're looking at this because you couldn't make it today, or if you're learning at your own pace, this was the getting ready homework. These are links to two different documents. Both have step-by-step instructions and videos on how to get ready by testing a single microbit to make sure your computer can test it, and then testing 2 microbits connected to your computer. And then also there was a section where you tested it out while on Zoom. And then this is the list of homework that I mentioned several times, where scrolling text was one of them, where you got started, and we tried out the scrolling text script. And then this is an example script, and it explains how it works. Then we have the students try a modification to the script, and then we have them get creative to extend them putting their hands on the keyboard and learning how to script. So we always try to start with something that works. Then we have them try an adjustment of some sort, and then we have them go on their own to do some kind of additional project to get them to put their hands on the keyboard, as I mentioned. If you have a laptop and you're using the Python online editor, if there's a battery performance option, it's best to have your laptop plugged in and then max out the performance. Otherwise, you might see some delays. In some cases with Zoom and the microbit, you'll see some delays anyway. It just varies by with the computer. Okay, so now about saving your work. If you want to save a script that you made, the best way to do it is to give it a name here and then click save. And it'll just save a copy of whatever you name it here, appended with .hex, and it'll end up in your downloads. And then if you want to open it, it'll start looking for it'll take you to your downloads, and then you can browse to find a script that you saved. If you moved it somewhere else, it's easy enough to browse elsewhere. And so let's take a quick look at how that would work. So here I have this radio communication script. And so I'll paste that in again, just so everybody has an example. Okay, so that is, that's in the chat again. And so if we want to save this, go ahead and click the untitled project right here and change the name. So I could change it to Send a Smile and confirm. So now we have the project name. When you hit save, what's going to happen is it's going to tell you about that it's saved in your computer's download folders, and that you can also use open to continue editing it later. I'll go ahead and hit the Don't Show This Again button. In Chrome, it'll show in the tab or in the bottom margin of the browser. And so there's also a little upward caret next to the file, and you can select, for example, show in folder typically, regardless of operating system. And then here it is. And so here's sendasmile.hex. Now, if I refresh this browser, now sendasmile.hex is gone. And to open it, you can hit open. And then go to downloads. And especially if you have it ordered by date modified, you can select Send a Smile. And here we are back with Send a Smile. Now, I'm going to delete this all. And then instead of hitting open to make it come back, or Control-Z, another thing you can do is, if you have a file browser open and are looking at at the files you saved, you can actually just drag and drop from the downloads folder into the browser and confirm that you really meant to do that, and then it'll open your script for you. While on that subject, you can also load scripts that you've saved into the microbit. This is an alternative way that we don't use very often, but just so you know, it's an option. You can drag sendasmile.hex from downloads and then drop it onto a microbit. And you can maybe see the flashing light under this microbit as the script loads. And it takes a bit longer to load than when we use the Send to Microbit button here. Just finished. A quick bit about oh yeah, so this is the basics, which I already took you through, and this is scrolling text. And so what I'd like to do is review the lessons from the homework with a slightly expanded script that does everything you did in the homework in one script. So here it comes in the chat. It's a big one, so make sure to get all of it and paste it in one of your editors. Control-A is nice for selecting all your script. So instead of dragging your mouse, clicking and dragging your mouse across it, you can do Control-A, or in a Mac, it's going to be Command-A, and then Control-V will paste it. Just like Control-C would copy it, Control-V will paste it. And then we can give it a new name, like this is all the basics. And when you run this, nothing is going to appear on the microbit. But when you, what you can do is hit show serial. So that's this button right here, show serial. And there's also a separator between the serial console here and the script. And what you can do is drag that upwards a little bit to give yourself more room. Now I'm going to do a little something extra, which is put an editor with the code next to the serial terminal so that we can talk about the code as we are running it. Okay, so looks like I lost my serial, I lost the serial message. So there's several ways to restart a script to make it display the message. When I clicked away from the screen, the serial terminal cleared. The first is that you can click these three dots on the right and select Control D to reset. Now it might give you an error, but see, I don't remember if you have to do it a second time or if you just need to send to microbit again. Okay, it looks like send to microbit works a little bit better, but if you ever have any trouble with just getting that result from send to microbit, hit Control D to reset and then send to microbit again. Now, the second way to restart a microbit modules script is to simply turn it over and then this button right here next to the serial port, you can press and release that to restart the script. So when I press and release that button in the serial terminal, interesting. Oh, I was using the wrong microbit. Okay. So let's try that again. I'm going to press and release that button, and in the serial console, we should see, yeah, see how it's restarting the script. All right. So, so it displays hello. And then says press enter to continue. And so here we are with the basics. So here is sleep 2000, which is just a delay that I'm in the habit of adding in to make sure that that the serial console is ready. I don't really know if it's needed anymore, but I've been adding it for quite a long time. Then it displays hello. So here we are. And then after that, input, press enter to continue, is basically asking you to type something and then press enter. And since there's no variable equal to whatever the result is that I type, nothing happens there, though it would load whatever I typed into maybe a variable named text. So if I typed something and pressed enter, it would end up in the text variable, but I'm not doing that yet. So when I press enter, it moves on to the remember, and the remember section sets A to 2, B to 5, F to 1.414, and T to text. And then it prints all of those. So we're going to expect when it prints A to print the number 2, B to print the number 5, F to print the number 1.414, and T to print text. So let's see if that's okay. Very good. Next up, when I press enter again, it's going to calculate a value of C, which is the sum of A plus B. So 2 plus 5 should be 7. So when you press enter, you'll see 7. Next up, we're looking at decisions. I want to emphasize here that that if with an if condition, if A is greater than B, well, let's see, is it? 2 is not greater than B because, or pardon me, A is not greater than B because A is 2 and B is 5. So basically, it'll check to see if that's true. If it is, it'll do this line. If it's not, it'll move on to check the next thing, which is if B is greater than A, which it is, so it'll print B is greater. Now, if neither of them are true, it'll keep on skipping down until it finds an optional else condition where, in this case, it would display that they're equal. So when I press enter, it'll probably say B is greater. There we go. And the next thing it does is review how to count from one value to the next. This one should count from 1 to 9 because it includes the first argument, but not the last one. And that makes a lot of things in more advanced scripting easier to approach. That's why it's inclusive of the starting value, but stops before the ending value. So here it should count to 9. Then the last thing it does is an endless loop where we set the value of n to 10. And there is a lesson in here that's kind of, I didn't go into it specifically, but there is a lesson about scope because this value of n only lives within this loop here. And so I had to create a global variable named n and manually give it the value. I couldn't just not have that line there in order to continue using the value of n from 10 onwards. So when I press enter, it should just continue from 10 and keep on counting upward. And with that, that's kind of a summary of the lessons about communicating with the display or the terminal, with remembering using variables, calculations using arithmetic operators, decisions using if statements, and repetition using either a for statement or a while statement. And with that, I'd just like to check if anybody has any questions or comments they'd like to talk about before we move on to before we take a break, actually, and then move on to some of the other material that will fit into cybersecurity lessons on Wednesday. So I see everybody watching, but nobody unmuting themselves and saying, hey, Andy. So what we'll do is we'll pause the recording for 7 minutes. During that 7 minutes, I'd like you to all take a break, stretch your legs, get a glass of water or whatever else you might need to do. And then we'll see you back at 7 minutes past 4. All right, welcome back, everyone. It is now 8 minutes past the hour, and we'll go ahead and resume. I did already show you the microbit MicroPython documentation. And again, that was simply clicking the question mark on the bottom left and selecting MicroPython documentation will take you to that page. And one of the things you did not do for homework was functions. And I don't really want to tie everybody's brain in knots with too much coding, especially for the beginners. For those of you who have already seen it, great. so what I'm going to do is I'm going to talk about these things just in terms of what they do so that you've seen it. And then I'll probably mention, oh, this has a function, or this has a tuple or a list, which are some of the upcoming concepts. And so we'll just talk about what they are. And then if you want to go to the writing functions tutorial, which I recommend going through every page of it. So here is writing functions. It's actually just a one pager with a bunch of different script examples. Let's see here. So to make it go more quickly, I will instead just grab that script. And then I had serial. And what the heck? Here, you guys can have the script too. So basically, a function is, it starts with def, D-E-F, for define the function. And then functions have a name, and then an optional value if you want to have the function receive a value from the main script. You can even do a list of values. And then, although not, and you can also optionally return a value. And so display.scroll is just going to display on your microbit. And what it's going to display is the result of calling the add1 function. So when the microbit says add1 and then the number 5, it says, okay, well, I better jump to the add1 function. And I better start with the value 5. Okay, well, value equals value plus 1. So now value is 6. And then it returns the number 6. So we come back here and this whole thing now becomes the number 6. Another way to think about that is something like x equals add 1 of 5. And then you could display the result of x. That way, it's a little clearer to the students as opposed to nesting it like this. We can say, okay, add 1 of 5. So this whole thing becomes 6. 6 gets stored into x, and then it displays the result there. Again, x could equal add together of value 1 and value 2, 5 and 6, and then we could display x here. And so now add together 5 and 6. Well, this becomes 5, this becomes 6. They get added together. And the result variable will store 11. It'll send 11 back. This becomes 11. 11 gets plopped into 6. And then display.scroll displays 11. I think I'd rather make it 12 so that we can see instead of just the 1 flashing twice. So I'll go ahead and update that. Or I would suggest okay, so I'll send this one to you. Copy, paste. So that's how functions work. No test on that. Just wanted to let you know because you're likely to see them again. Also, just along the side, at Parallax, when we switched over to Python as a language, none of us had really worked with it before. So we found ourselves kind of wrestling with the nomenclature. And so I just wanted to add this slide, which you can refer back to or use as a cheat sheet or something like that with some of the nomenclature. So if you put a hashtag or pound sign to the left of some text, it will become a comment that's ignored by the Python runtime, MicroPython runtime, pardon me. And next up is a module. A module is some extra code where you can call its functions, and then it has some more fancy things called methods. And then there's also properties that you can get to inside objects. Anyway, a module is something like the microbit module here. And we also worked with the radio module earlier. And so you can import modules and then look at the API for the module you import. Where is radio? Here's radio. So here is the radio API right inside the editor. And for example, you can say radio.on or radio.off. And then radio receive is one we used earlier. When you see something like display.scroll or radio.receive, those are methods. And really the difference between a function and a method is that a method can take on certain properties, and you can make copies of them. It's handy, but it's outside the scope of what we'll be doing during the workshop. To write code for a method, you can do it. But right now, just know that when you see display.scroll or radio.receive, that's a method call inside a module. And if you see something like sleep 2000 to make something delay for 2 seconds, sleep is a function. And then arguments, examples of arguments are 2000 and image.heart. Image.heart is also a property of an object. So heart is a property of the image object, and that all lives inside the microbit module. So we can't really get too concerned with that. This is just, again, for referring to things correctly for anybody who's interested in making sure that they say the display.scroll method and the sleep function and etc. You're always welcome to go ahead and post questions and comments in the meeting chat, or even unmute yourself and say, hey, Andy. Either way is fine. Moving on to another quick thing that we'll be seeing more of in cybersecurity is lists and tuples. I'll go ahead and paste this one into you. And I'll talk about it while you're running it. There it is. A tuple is basically a list of values enclosed by parentheses. Now, a list is a list of values enclosed by square brackets. The only difference between the two is that you can only access a tuple. You can modify a list. And so basically this script, what it does is it says, okay, here's a tuple and here's a bunch of values that are stuck in there. And so you can print the whole thing, or you can say, hey, I just want to print the second element of tuple. And you can do that by saying the variable name tuple and then 2 inside square brackets. Now you can do the same thing with the list, except that you can also do things like change hi to by saying, okay, the second element in the list variable, which is a list, is now equal to by. So it printed it first with hi, and then it printed it again, and we see that we have bye. And then also taking a look at the second element just individually, that also says bye. Here's a little fun one. It doesn't come through very well on my speaker. So I won't try to play, or my microphone filters it out. That may actually be a function of Zoom, but I'll give you a link and you can try copying and pasting this music into your microbit to hear the speaker go. So here's a link, and when you follow it, it takes you to the music page in the MicroPython documentation. And if you scroll down to the bottom, you'll see this nice little music script here. And don't forget to shade this music.play notes at the end. So we're shading all of that and then taking it over to the MicroPython editor and pasting it in and sending it to the microbit. And I don't know if any of that's making it through or if it's getting filtered out, but you'll be able to hear it on your end. And so again, that is an example of a list and a way to make in this case, a pretty long list, and then pass it to the music.play method. The list is named notes, and it gets passed to the music.play method. And then it takes all these full notes, quarter notes, and it, for the most part though, it's generally talking about, it's got a bass octave. And then if it's off by an octave, it'll say the 5th octave or the 4th octave. And then there are also things in this notation, like I believe that's a quarter note. And so there's fun with music. Everybody get that working? Got to hear the music? No? Okay, I have a few thumbs up, but mostly few head shakes. Let's see here. Is there a particular spot? Did the link not come through, or is it just not running?
Andy?
Yeah.
I didn't know. Does the microbit have a speaker on it? Because I know whenever we build, well, like just take the Cyberbot, for example.
Oh, my
You
bad.
have
You know
to
what?
add a piezo speaker to it.
Okay, so some of you might have microbit version 1s, especially if you were gracious enough to supply your own microbit. And so if you're using a microbit version 1, it does not have a speaker. And I apologize for that. I forgot the ones we send out are microbit version 2s that have the built-in speaker.
Well, I'm using 2.
Okay, so it should go ahead and play the music for you. I think the main thing is just to get the whole script starting from the 3 quotes at the top, or if you want to just start it from microbit import star, but shade that whole script.
We have a message here from Naomi, unexpected indentation error.
Okay, that might mean that maybe you shaded more than you really wanted to, because if you shaded outside of there, or here, tell you what, let me see if I can paste this in. I don't know how many characters are allowed. Nope, the message is too large. All right, let me see. I'm going to trim this down so that it will fit in the chat. Okay. I doubt that's going to run until I get that comma at the end. Now. Okay, so I can hear it in the background. I'm going to paste this into the chat. try it from there. For those of you who have microbits with speakers on the back, let's see here.
Yeah, it works.
Okay, good. Thank you. For some reason, my camera app turned off. Okay. So, okay, I got a thumbs up from Susanna. Let's see, and I think Tom and Rosanna, I was getting head shakes from you. Have either of you got it running? Okay, thumbs up from Rosanna. Sorry, yes, no, Tom? Yes, oh, good. All right, and then we'll have, after the recorded portion of the session at the 2-hour mark, we'll also have some time to do any troubleshooting of your system. So if you need any help at all, just go ahead and plan to hang out with us for a little while afterwards. That's also a good time for open questions and answers. Okay, so that's lists and tuples. Again, don't worry about owning this. Just know that they're there and that there are things that you can study and learn through the tutorials. Here's another one that comes from the Make It Code It, where it's a list of strings, and every time you shake your microbit, it picks an activity for you to do. Kind of fun. And if you click the picture, you can go straight to that particular project. Back to the tutorials, getting ready for the cybersecurity. There's dictionaries. Dictionaries are the equivalent of JSON data. JSON data is kind of the foundation for the way web pages exchange information with servers. It looks very much like this. So when you type a search into Google, it gets converted into JSON data, and it might be, search term equals, or search term might be where you see name here. And then the text you typed might be in the text accompanying it. And what we call this is a key value pair. Make sure to delete the old code when you paste in the new code. Thank you, Ari. Yes, that's a very good idea for anybody still having trouble getting it to run. Control A is a nice way. So Control A and then Control V to paste over can be helpful to make sure that you got all the code.
Yeah, Nelson mentioned an error in line 30, but we have, even with the full code, we have up to line 26. So if he sees 30 lines of code with a complete code, the original code is shorter than that. So thumbs up from Nelson.
Excellent, excellent. Good job, everyone. So a dictionary, I got ahead of myself a little bit there. A dictionary in Python is simply a bunch of key value pairs separated by commas that are enclosed by curly braces. And you can do things with dictionaries that are similar to what we did with lists and tuples, except for instead of going for the second element or the third element or whatever, we just say, hey, give me info, that's the name we gave our dictionary, of score. So if we want to know what value is associated with score, we say info of score. It goes to the info dictionary, finds the score key, grabs the 1000 value, Now we're back here, this is 1,000, and it gives it to number. You can also go in and change info of score in Python. And again, why is this important? Well, it's the way that data goes back and forth between web browsers and servers, and it's also really the best way to make applications work. For example, Carolee, I believe that's her name, asked about a countdown application, which we'll be doing momentarily. See, I'm looking for that. Don't see. Sorry if I botched your name. Dictionaries. Dictionaries are, oh, here is the, here's an example from the activity. I'll go ahead and paste it in so that you can see that output through the serial console. Okay, so remember to hit Control A, then Control V to paste it all through. And then we can send to microbit. So somehow it looks like I might have disconnected my microbit. Huh. Okay, now it's working. Show serial. So what we have here is a dictionary with 2 key value pairs, name and score. And then it prints that, it prints info, and it leads in with the info dictionary. So you see the whole dictionary right here. So, then you can even add a key value pair to a dictionary by simply saying info of goal, where goal is a new key that didn't previously exist. And so we arbitrarily set it to 5,000. And then your new dictionary will have a goal, a score, and a name, whereas the original dictionary just had a name and a score. And the important thing to keep in mind is unlike lists and tuples, which you have to, go for the 0th element or the first or second or third element, with a dictionary, you can just say, hey, give me the value that corresponds with my goal key. And then the Python runtime goes in and finds the key you're looking for, be it score or name or whatever you put in there, and then it will return you the corresponding value of, in this case, 2,000 for score.
Question on that.
Okay.
Does the dictionary have an infinite number of elements? I'm going to guess no, since memory is not infinite.
Yes, that's exactly why there's not an infinite number of elements, and there might be further restrictions. However, I'd have to really poke around and it would take a while. But if anybody wants to ask ChatGPT, or, well, no, you won't necessarily get the right answer there. But
I'll check microbit text support.
That sounds like a much better approach. Thank you,
Okay.
Stephanie. Okay, next step is exception handling. Now, this is very central to cybersecurity because, well, one common attack is an element of a denial of service attack, where basically the server is sent things that it's not designed to accept repeatedly, so it is continually dealing with error conditions. And so the students find out in the cybersecurity lessons that they can prevent a lot of crashing of their microbit that another student could do either inadvertently or maliciously. They can prevent that from happening by using exception handling, so that when something goes to prevent something from going wrong in their script, especially when their microbit is acting as either a server or a client. So here's an example I'd like you to try of throwing an exception. And instead of pasting you in the code, let's try just giving you the link and then having you go get it. If anybody has any troubles, just let me know, and I'll paste the code in for you. Close, hide serial, Control A, Control V, and then send to microbit, and then we'll show serial again. All right. Now, this in the activity, this starts off as a working script. And so the students go through and they start with this working script. And everything went just fine. They divided 5 into 20 and got a result of 4. Well, what happens if you instead make the denominator 0? I'd like you all to do that after verifying that the original working script runs. Go ahead and change line 10 from D equals, was it 4? 5. Change line 10 from D equals 5 to D equals 0 and send it to the microbit again. And then notice that the microbit is now essentially stopped in its tracks. So the microbit.
We haven't requested, can you repeat that?
Can I repeat what?
Just came up, can you just repeat that from Rosanna?
Okay, I'm just not sure what to repeat. Here, I'll send the script through, by the way. What number are we changing? Oh, okay, thank you, Rosanna. Yeah, we're changing the value of D from 5 to 0. So it was 5, and we're going to change it to 0 and rerun it. And so instead of displaying the result, the microbit runtime stopped in its tracks on line 12. So it didn't get to line 14, 15, 16, 17, or 18 because the value of D was 0, and you can't, the microbit cannot use 0 in a division calculation. And generally in algebra and et cetera, we learn that we're not allowed to use 0 in the denominator because there's no real answer for how many times 0 fits into any number. And so this is an example of an exception where the runtime gets some data and it does what it's told with it and then says, I can't do anything with this. And so that's when it throws an exception. And when it throws an exception, it can't get to the rest of its script. And as a result of that, especially if you have networked robots trying to make it through an obstacle course, if a networked robot gets some kind of value that it's not expecting and it doesn't have exception handling, it might stop in its tracks too. And students might be somewhat unhappy with that result. And then also more interested in addressing that with exception handling. And so here is the exception handling code on another page. And I'll go ahead and paste that through. Oops. Not sure what just happened. Paste. There you are. So again, this is the same division calculation, and I recommend that you try it both with and without the divide by 0 to cause an exception. So if we run this as is, and then use show serial, we'll see it does it correctly. And then if you change, this time it's line 11, from d equals 5 to d equals 0, and run it. When you run it, it instead tells you, hey, there was an exception. You had to divide by it, and it's the divide by 0 exception. But notice that it makes it all the way down to the end of the script. And the reason for that is because in exception handling, we try running a snippet of code. And if there's an exception, in this case, we print it, and then later in the lesson, the students get to see how to just put in a helpful user hint. So this is something that the developer might want to see is the person writing the code, is they might want to see the exception. However, if there's no exception, if everything's fine, it goes ahead and displays the result. And in either case, the finally says, try it again. And so that is the form of exception handling. And we run into this quite a few times in the cybersecurity lessons, because there's a lot of ways that exceptions can sneak into applications, especially when the applications are trying to use data that are supplied by either a user who inadvertently makes a mistake, or intentional and malicious misinformation going into the script. There is an entire chapter on that. And so just wanted to let you know that I'm going through this. And here is, by the way, a couple of different, this is the result of making it user friendly. And this one, I don't know if I put it in here or not. No, I didn't add this in here. This is where the student is challenged to add some user-friendly hints and to do the whole thing in a loop. See if I can find anything for you to try here. Okay. So here, I'll go ahead and surgery this so that you can see how to add some helpful exceptions instead. Paste. And it's telling me that I have all kinds of problems in my code, and that's because, see these little red squiggly underlines? The indentation, I believe, is incorrect here. Shift tab. Okay, so that looks better. Show serial. Okay. I'm seeing our time, and well, I'm just going to put this in a loop. No, sorry. I'm going to bounce off of this one because it's going to take too much time. Suffice to say that there's an activity where the students are challenged to add some helpful hints so that in this case, the programmer chooses the right number, and later on it's going to be the user. Strings, I'll probably have you experiment with that with strings over the homework, the main thing I want to say about strings is that you can do all kinds of things with them. You can do string surgery, as this example on the slide is showing, where it takes the string "have a nice day" and then removes the "nice" and substitutes "great" in its place. The strings chapter is pretty involved, and one of the main reasons for that is because string manipulations are part of encryption, at least the basic classical encryption that we introduce in these cybersecurity tutorials. So the students end up going through a lot of work on strings. And so here is the cover page. And then as we advance through different pages, this talks about all the different kinds of strings. For example, a string can be contained in single quotes, in double quotes. You can have a string block that includes carriage returns if you use either 3 quotes or 3 apostrophes. I think I said that backwards, but hopefully y'all get the idea. There's 3 apostrophes and 3 quotes. You can also make a string that is separated by backslashes, another way to do a multi-line string. And we also talk about ASCII codes, which become important because each character in a string is represented by a code. For example, a capital A is the number 65, lowercase a would be 97, and so on. And I'm going to swing back around to that on Wednesday about ASCII codes. Now, strings can be used to exchange data over the radio. It has to use a string, but there is a way to take a string that contains something that actually represents a number, like the characters 1, 2, 3, 4, and convert it into 1,234 that the microbit can use in calculations. And that's an example of one of the many things that is introduced in strings. And let's see here. So here is a page that I'll probably have you work with in the homework. And it's going to show you how to do some string surgery, but more importantly, how to use useful stuff like to take a number and convert it to a string, and to take a string and convert it back into a number. Yeah, that's not shown on this page. I will make sure to find you an example, send it out in the email. You can also do lots of things like find a word within a string and make a string into a list of characters, make them all uppercase, lowercase. And so this page we'll probably look at for homework. All right, let's do something fun. A couple of fun things. The first one is I'm going to back up actually to cybersecurity, and because Carolee asked about a countdown timer. And in computer microbit talk, this is where we go through where the students learn lots about using the terminal. One of the applications that we use repeatedly, because it's a very simple application that we all are familiar with from our smartwatches and from our phones and from the timer on our stoves, is the countdown timer. So I'm going to give you both the link to this and the script. Okay, so there's the link to the page we're working from. It's near the end of the computer microbit talk, where we learn all about using the serial console. And then below it is the script. And to run this script, just paste it over whatever you've got and send it to the microbit, and then show serial. And it's going to ask you for the number of seconds to count down. Pick a small number. We want to get, we only have 10 minutes left. So, so I'll pick the number 7 and then hit enter. And then the message after countdown can be liftoff. And then when you hit enter, it counts down and lifts, and then says liftoff. Should have done some exclamation points there. Okay, and if we run it again, we'll do 3 and then go with an exclamation point. This particular application gets repeated over and over again, networked and otherwise. And then I was going to look for our radio, or no, not for radio, for sound. Here is speaker. And great, speaker on and speaker off, but what about, it might be in the music. I think I'll use pitch. Probably gonna get in trouble with this.
Lucas pointed out that you can copy the musical note we had before.
Oh, yeah, that is a good idea, and it might be the better idea.
Look for sound, Alex says.
Okay, let's try sound. Thank you, Alex. That's probably. Yeah, for example, we could do audio.play sound.happy. That'd be cool. And I need to capitalize sound and then do happy in all caps. All right, let's see if this works. Enter seconds to count down. 3. Okay, good. And then, so I should probably also just do a display dot show the value. And then I'll paste it to you all. Just want to make sure it works first. Okay, 3 seconds. And it didn't like it. Let's see here. Line 15, display.shoe. Let's try that, see if it's any better. Okay, I think we have an app that students are likely to also want to take the existing example and modify and have it be like this. So now it is in the chat and you can try it out. And as was pointed out, you can use musical notes, and there's also a way that you can use the frequency. But I don't remember how to do that.
Sheila reports that my code is working but not showing up on the microbit.
Okay, and is this the one where I just pasted it in? Because that code should show on, or so what I did was the original example used show serial, the serial console, and then the modified example that I just pasted in both prints in the serial console with print and displays on the music.play, music.bading. That's nice. Thank you, Duke. It's not audio.play, but music.play.
I just played some music from the built-in music you can get off the sidebar, and it worked great.
Okay, let me just check. Yeah, but that's pretty nice too. Okay, so I'll paste in this other one. That's the thing about the microbit though, is it's so fun. It's really easy to kind of get into little, oops. There we go. So there's the modified script. Now in the remaining 4 minutes, what do I want to talk about?
Homework for next week?
Yeah, or not next week though. This coming
What
Wednesday.
am I thinking? Next session.
Okay, so I think what I want you to do is, now that you've got 2 microbits connected, what I'd like you to do is, you know what? Let's just see if we can shoe this in. Radio basics, texting with terminals, bidirectional texts. Okay, so what I'd like those of you who have 2 microbits connected to do is try this one out. It's pretty fun. Paste it into both of your microbits. And it's probably better to tile your editors side by side for this one. So we can paste the script I just sent you from the radio basics into both microbits. Looks like I need to connect this one. There we go. And then we can send to both microbits. I actually made them both transceiver A. I should have renamed the second one transceiver B right here. But it works just as well. So what you can do is click in one terminal and say, hello. And when you hit enter, notice it appears in the other terminal. You can go to the other terminal and type in something like hi, and basically go back and forth. And what this is the students really go get excited when they when they get to start texting back and forth. And it also can bring up quite the host of cybersecurity topics. For example, one student might mount a denial of service attack and then nobody else can talk. There's cyberbullying could potentially come up, which is one of the standards that can be addressed. The DOS attack, lots of stuff can happen. So first of all, I just want to check, how did you guys do? Did you all get that running? Are you texting back and forth? Okay, I have one thumbs up. I'll give you some time. And I want to emphasize that what's happening here is you're typing in a message. Here we are, bidirectional text. So you're typing in a message. It's going over USB to the microbit. Then the microbit is sending it over radio to any other receiving microbits. Receiving microbit gets that message and sends it to USB to the serial console that it's connected to. And so when you're going back and forth, none of this is passing through the computer. It is instead going over the radio. Like so. And so again, each student is going to have one microbit connected to one computer, and they'll end up exchanging data back and forth. And so those are two of the applications that are going to be repeated throughout the cybersecurity lessons, two of several, but these two are notable because one is direct communication with text, and then the other, which was the countdown application, will be, when it goes over radio, it's going to be encapsulated in a dictionary. And so said dictionary can be intercepted, it can be modified without permission, and various other things. And so this is, here we've basically laid the foundation, and on Wednesday we'll get into some lessons on cybersecurity attacks and defenses. For homework, what I'm going to do is I'm going to email you, I think, the main details. It's going to be pretty light, even though it's summer. I try to keep the homework light so that during the week, as opposed to having a couple of weekends to get ready. And so there's just going to be some reading, and then I might challenge you to just code a little bit. And there's a string features page. And down at the bottom here, it does a bunch of things with strings. And my challenge for you will be to use print statements to show the results, to display the result that car index stores, that news string stores, that car list stores. And then on Wednesday, we'll have seen most of the ingredients of the scripts that will either that can be attacked and defended against. And so we'll focus Wednesday on scripts. Let's see. We just did bidirectional texts. If you weren't able to complete it during the workshop, I can help you out afterwards, or just do that as your homework or as part of it if you'd prefer to also do the string features challenge. This was going to be homework, but many of us did it during the workshop. And I am going to email you I'm going to email you links to these slides. And by the way, here's the hint on doing the so the challenge was we have
So,
a
but-
string.
Go back to that hint, Andy.
Yes.
I thought I saw print on the third line. Are there supposed to be two N's in index?
Wow. I was only there for a second. No.
That still works because it's part of the text that prints, right?
There we go.
It will just show the typo, but it will still work, but
Okay.
it will be a spelling error.
So Stephanie does a lot of technical editing here at Parallax, and now we see why.
I get lucky once in a while.
Okay, so I'll email you some specifics on the homework or some clarifications, but basically, just read these pages or take a look at whatever level you prefer to, and then we'll go ahead and reconvene on Wednesday at 3 p.m. Pacific time. We also have the recording. We can stop the recording, and we can also do some open discussion and technical support. I'll stay here as long as you folks have something to ask or talk about, and then we'll look forward to seeing you at Wednesday, 4 p.m., 3 p.m. Pacific, 4 p.m. Mountain, 5 p.m. Central, or 6 p.m. Eastern time on Wednesday.